Welcome to the third lecture in the module 2 in the subject hydrology and water resources. So let us recall what we have done by now. We gone through the history of hydrology, that how hydrology actually started. So it started from philosophies, then mathematical equations came, and then slowly these equations were taken over by scientists, and then the computer system. So this is how it started. Then we came to hydrologic cycle, and we started how water circulates inside the atmosphere. Then we came to the form of precipitation, and then we came to rainfall. Then we came to how rainfall actually happens, what are the types of rainfall. In the last class we also talked about recording and non-recording rain gauges. So this is what we have done till now. So in this class we will move further. So now assuming that there is a place and you want to establish rain gauges. So let's say this is some city or some area in which you want to locate or establish your rain gauges. So the question, the very important question is, how many rain gauges? Okay, for this area, how many rain gauges you should establish? This is a question for you. That shall I establish one rain gauge here, or one rain gauge here, or one rain gauge here, or one rain gauge here? What are the what will be the optimum number of rain gauges? Okay, so this is your question. So how will you establish a mathematical equation, or how will you come to a conclusion to answer this particular question? So right now we will deal with this problem. So our topic is optimum number of rain gauges. Okay, so the first point in this series is, in this topic, is that to answer this number, the answer must be based on that the number should represent or should be based on a particular area. Okay, some area must be there, and we should think of this, that how much error we can tolerate. For example, suppose there is an area and in actual the rainfall happens for 10 centimeter. This is the reality of this any particular area, that in this area this is 10 centimeter rainfall. Okay, this happens in reality. Now if you want to derive a mathematical equation, you should you should decide how much error I can tolerate. Okay, so and in reality this is 10 centimeter is rainfall, but you will never be able to calculate this 10 centimeter. Okay, why? Because 100% accuracy for any measurement is almost impossible. Okay, so you must give your answer based on some acceptable value of error. Let us say I can tolerate the error up to 10%. Okay, so based on this 10%, I will say that 10.1 or 9.9. Okay. I may give answer like this: 9.9 is the value of rainfall, or 10.1 is the value of rainfall. The maximum difference is 10%. So your answer should be based on some acceptable value of error. Okay, why error? Why you accept an error? Because 100% accuracy you cannot maintain. Okay, so based on this, the first point is, if you want to calculate the optimum number of rain gauges, it is based on acceptable value of percentage error. Some percentage error must be there. So let us, we call this optimum number of rain gauges as n. So this value of n is given as n is equal to CV divided by epsilon whole square. So here the n is optimum number of rain gauges. Here epsilon is allowable percentage error. How much error you can tolerate. Okay, then what is CV? So if you remember your knowledge from statics, then this CV is called coefficient of variation. And the CV is reported in terms of percentage. So in mathematics you might have heard this word CV, coefficient of variation. So how to calculate CV? It is given as epsilon by sigma epsilon divided by x bar into 100. So what is epsilon? Epsilon is standard deviation and x bar is your mean. So let me write this. X bar is mean or average, and what is sigma? Sigma is standard deviation. So what is standard deviation? It is mathematically it is given as x minus x bar whole square divided by n minus 1. What is x? X bar is this mean or average value. What is x? X is any value of rainfall. Okay, and n is number of values of rainfall. So So this is the statistical equations, and all this equation is based on your mathematics, simple statistics. Okay, so now if you could observe here that let me explain this also. So what do you understand by mean? So let's say if there is a rainfall is like 5, 6, 7 and 10. There is some area and there are 4 rain gauges. Okay, let us say these are 4 rain gauges, and this rain gauge record this value of rainfall. This rain gauge records this value of rainfall. This rain gauge records this value of rainfall, and this rain gauge records value 10. Okay, so what is now how many rainfall values are there? 4. That means n is 4. This n. Okay, and if I will ask what is the average value of rainfall, so what is average? That is x bar, that is mean of this value. How you calculate the mean? Sum the value divided by number of values. Okay, so this will come out your x bar. And now you know this one. And what is standard deviation? So to explain this, let me say, suppose these are some values randomly distributed. Then if you see the mean, okay, this is some value. Suppose this is some values of rainfall, and this is the mean value of rainfall. So how much they differ from the mean? Okay, how much they differ from the mean is nothing but your standard deviation. So this value, okay, this value is represented by sigma or standard deviation. Now what we have did here, we have squared it and then we have provided a under root. Okay, why we are providing under root? Because if you see here, if you say this as 5 centimeter and you say it as 6 and this as 4, so you see that from x bar 6 differs by value 1 and 4 also differs by value 1, but actually it is minus 1. Okay, so but the difference is 1. The mathematical difference is 1 and minus 1, but in general the difference is of value 1. So this sign is creating problem for us. We don't want this signs. So to remove these signs, what we are doing, we are squaring, okay, and then we are under rooting. When you square minus sign, it will become positive. And when you will under root, it will again be positive. So this is the basic idea of providing under root. Okay. Then instead of writing here n, we are writing n minus 1. So why we are writing n minus 1? So in many times in interview they ask this question that for standard deviation, why you write n minus 1 and not n? So this is also one of very big question. So right now, as an undergraduate, you can understand or you can answer this question as that n minus 1, okay, increases the value of sigma. So the value of sigma that you calculate with this formula is slightly greater, okay, than when you will replace n-1 as n. Okay, so you answer or you report sigma a greater value, which turns out to be your safety or your overestimation of the correct value of number of RHRM gauges. कहने का मतलब है कि अगर आप n-1 की जगह n यूज करेंगे तो आप जो नंबर ऑफ RHRM gauges निकालेंगे, ओके, n में क्या करेंगे, आप कम RHRM gauges निकालेंगे, लेकिन n-1 में आपके नंबर ऑफ RHRM gauges ज्यादा निकल के आएंगे क्योंकि आप छोटे वैल्यू से डिवाइड कर रहे हैं. तो आपको एक्चुअल में अगर 5 RHRM gauges चाहिए थे और अगर आप RHRM n-1 से करेंगे तो 5 से ज्यादा RHRM gauges निकल के आएंगे. तो आप जो भी आंसर रिपोर्ट करेंगे वो आप एक्स्ट्रा रिपोर्ट कर रहे हैं और आपकी एक्चुअल वैल्यू क्या होगी, जितनी रिक्वायर्ड है उससे ज्यादा आएगी. तो इसका कहने का मतलब है आप आंसर को ओवर एस्टिमेट कर रहे हैं और ओवर एस्टिमेशन आपके डिजाइन पर्पस में आपके लिए एज अ सेफ्टी बन के आपके लिए सामने आ जाएगी. सो इसलिए आप यहाँ पे n-1 यूज करते हैं ताकि आप ओवर एस्टिमेशन कर सकें. ओके, सो दिस इज योर स्टैंडर्ड डेविएशन. ओके, सो आई होप you got this one. So let's solve one question to visualize this mathematics. So let me write the question. So this is your question in which they are saying that there is some area, okay, in which 6 RHRM gauge station they have. There are 6 RHRM gauges station A, B, C, D, E, F, and these RHRM gauges in a particular year, these RHRM gauges record this much rainfall. Okay, so they are asking that although they have established 6 number of RHRM gauges, now tell me that what are the optimum number of RHRM gauges required. 6 RHRM gauge लगे हुए हैं, ये पूछ रहे हैं कि एक्चुअल में कितने नंबर ऑफ RHRM gauges होने चाहिए. ओके, नाउ लेट अस से दैट एरर जो है वो क्या है, 10%. Okay, so this much is given in the question. Now you have to answer this question. Okay, so to answer this, let's see what we have. So optimum number of RHRM gauges अगर आपको निकालने हैं तो पहले आपको CV निकालना पड़ेगा और आपको एप्सिलॉन चाहिए. तो एप्सिलॉन आपको पता है 10% है, आपको CV नहीं पता है. तो CV निकालने के लिए आपको क्या चाहिए, सिग्मा चाहिए और x बार चाहिए. आपको दोनों नहीं पता है, दोनों आपको कैलकुलेट करना पड़ेगा. फिर इस तरीके से आपको कैलकुलेट करना है, फॉर्मूला ये है. सो लेट्स स्टार्ट सॉल्विंग. सो सबसे पहले हम क्या करते हैं, हम सबसे पहले निकालते हैं कि what are the values, what are the x values. So they are the values of rainfall that were given in the table. So ये जो values हैं ये आपकी क्या है, x वैल्यू है, रेनफॉल वैल्यूज हैं. आपको इनकी मीन वैल्यू निकालनी है. ओके, सो लेट्स कैलकुलेट द x बार फर्स्ट. So solution. x बार क्या है आपका मीन है, मीन का मतलब क्या है आपका एवरेज है, मीन या एवरेज दोनों एक ही चीज है। एवरेज आप कैसे निकालते हैं, सम ऑफ द वैल्यूज डिवाइडेड बाय नंबर ऑफ वैल्यूज, sum of the xi values divided by number of values n. So what are these values? So the first value was 82.6. So first value was 82.6. Second value was 102.9. Third value was 180.3. Next value was 110.3. Then 98.8 and 136.8, 136.7 सॉरी। सो ये क्या है आपकी एक्साइज की वैल्यू है, आपने उनका सम कर दिया। अब लेट्स डिवाइड बाय एन। सो व्हाट इज द वैल्यू ऑफ एन? 1 2 3 4 5 6 values are there, so 6. So from here you can calculate the mean value. So 82.6 plus 102.9 plus 110.3 plus 98.8 plus 136.7. This the value comes out to be 118.6 centimeter. So this is the mean value. Okay. Now what do you need? You need to calculate sigma, that is your standard deviation. So let's calculate sigma. What is sigma? Sigma is summation of xi minus x bar का whole square divided by n minus 1, and this has to be under rooted. So this is your formula. Okay, so this is your formula. So let's go back and start solving this. So the first xi value was 82.6. What was the x bar? We just calculated it 118.6. So 118.6 square plus what is the next xi value? 102.9 minus 118.6 का स्क्वायर next 180.3 minus 118.6 square plus 110.3 minus 118.6 का स्क्वायर प्लस 98.8 minus 118.6 का स्क्वायर प्लस 136.7 minus 118.6 का स्क्वायर divided by n minus 1. So 6 minus 1, 4 has to be under rooted. So now you can solve this value. So on solving this, you will get 35.04 centimeter. Okay, so this is the value of standard deviation or sigma. Okay. Now what do we need? We need CV. So what is CV? CV is sigma by x bar into 100. What is the value of sigma? We just calculated it, 35.04. Sigma was 35.04. X bar we already calculated, 118.6 into 100. So let's calculate this value. So 35.04 divided by 118 multiplied by 100, so it comes out to be 29.54 centimeter. Sorry, CV is in terms of percentage. Okay, it do not have any unit. So this is the value of CV. Now in actual, what you were asked to calculate N. The formula for the M was CV divided by epsilon ka whole square. So let's put the values. The value of CV is 29.54, and what was the percentage error? So allowed percentage error was 10. So now you can calculate this one. So 2.954 squared. So it comes out to be 8.726. So the number of rain gauges required is 8.726, but rain gauges cannot be in the decimal form. There should be a specific number of rain gauges. So the correct answer that should be reported is 9. So what does this answer represent? So let's go back. So what is the answer? The optimum number of rain gauges is 9. This is your answer. So what does this 9? What does this 9 represent? That in this area where you established 6 rain gauges, you should have established 9 rain gauges. So in this area 3 more rain gauges are required. Then only the correct answer of rainfall can be estimated or can be reported. So this is how you calculate the number of rain gauges in any area. Okay. So there's one more thing, and now we are repeatedly talking about this area, and we are not talking about this word, that is catchment. So let's talk about what is catchment. So basically, what does catchment represent? Let us say, suppose there is some mountain. Okay, there is some mountain, and there is some mountain like here, and there is some area. So if you will see, whatever there will be, if there will be rain like this, so this side of mountain, okay, will contribute water in this area only. Whatever water that will fall over this side of mountain, so all the water will come to a particular area. Okay, so this particular area will be called one catchment area. One catchment area. Similarly, this side of mountain there will be another area. If water falls on other side of the mountain, all the water will come to this or accumulate in this area. So including that side of mountain, that will be called catchment area 2 or another catchment area. Okay, so that is why we were establishing the rain gauges in a catchment area. So if you will see your question, the question said that a catchment area has 6 rain gauges. Okay, why they were talking about catchment area? Because whatever rain gauges you establish in any area, let us say you are putting 6 rain gauges here, 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 here. So for this particular area, these rain gauges will report the answer, or only these rain gauges can give you answer. Okay. So if there is a city and we want to answer that what is the amount of rainfall today in this city, so this is a kind of inappropriate question. Okay, rather the more basic question should be, what is the value of rainfall in this catchment area or one catchment area? Okay, so the catchment area can be very big also, can be very small also. It depends on the geography of that particular area, that where the mountains are, or what is the area slopy or downward sloping, or it is upward sloping, or it is a flat area, are there any depression in the ground. So those kind of things are responsible for deciding the catchment area for any particular ground or earth surface. Okay, so this is all about how to find out the number of rain gauges that are optimum to answer the value of rainfall in a particular area or in a particular catchment area. Okay, so I hope you might have found this useful. So this is all about today's class. So we'll meet in the next segment. Thank you very much.